Hello everyone, welcome to the IEEE Communication Society podcast episode number 17. This is Professor Aryan Kaushik, and as you know that I'm host of this podcast series. Today I have with me a very special guest, Professor Lina Mohjazi from University of Glasgow in the UK. So she has been expert in several of the technologies around sustainability and sort of machine learning activities and several other techniques that we are talking about in 6G. So we'll try to learn about some of the latest developments, what is happening in 6G and around this, and what kind of applications we are thinking in this aspect. So welcome, Lina, first of all.
Thank you so much, Aryan. It's a pleasure to be here. I'm very delighted to get into this conversation and sort of discuss what are the hot technologies in 6G and the way forward, what are the trends, what are the potentials, what are the limitations. So really, really happy to be here, and thank you so much for the invitation.
Thanks, Lina, for being here. So I wanted to start with something very, let's say, fundamental stuff, right, about 6G, what we are aiming for. So you see that sustainability is one of the key aspects when we talk about like 6G framework that we have, the ITUR approved sort of IMT 2030 framework, which I talk about basically in almost all my podcasts.
Indeed, yes.
So I think there we do have like many key usage scenarios, but one of the key objectives that we have is around sustainability, that we talk about like achieving highest capacity possible. We talk about having the highest sort of performance, in any sort of metric that you want to pick, right? But at the same time, we want these solutions to be sustainable as well for over a long period of time. So I wanted to understand what are your thoughts on sustainability for like as far as is concerned for 6G and beyond sort of networks, and any research, any work that you have been developing recently, any work that you have been doing, your group has been doing. So if you would like to share something around those lines, please.
Yeah, absolutely. Let's start from the 6G vision. So we've recently set together with Ericsson a vision about what is the formula of 6G. And it was a sort of a forward-looking vision, because we have identified a formula for 6G, which is basically saying that 6G is equal to 3 Cs and 3 Ds.
Right.
And if we understand those, then this sets the stage for us, and then we can understand the sustainability later on. So the 3 Cs are cognition, connectivity, and then compute. And then for the 3 Ds, it's densification, digitalization, and distribution. So 6G will basically be facilitated by employing all these, what we call them, architectural pillars. And if we break them down into pieces, then sustainability is going to be fed into each of these elements, architectural elements, in many different ways. And this is, of course, driven by 4 key use cases that is basically driven by societal trends and interests, so which are the Internet of Senses, Internet of musical instruments, Internet of mirrors, what I would say.
We could hear only Internet of Things earlier, or Internet of Everything,
Indeed,
let's say.
yeah.
But new terms are coming up. So
there are new, Internet of Everything, and I would like, to reflect on them sometime soon in our conversation. So there's the Internet of Things, but now more into, really trendy things. And then there is the connected machines, where we see the interaction between machines and humans. So this is all driven by some societal interests. And then there is the sustainable ICT and ICT for sustainability. So the idea here is to understand how the information and communication infrastructure is able to support sustainability goals. But at the same time, we don't want to compromise on having sustainable communication infrastructure on its own. So this is another thing. And the last thing is the digital connectivity, where we have digital replicas of everything in order to provide the immersive experiences, the predictions, and all of that we needed.
So we call it digital twin as well somehow.
Digital twin, indeed.
Bringing the real physical world into digital
exactly.
platform.
Connecting, understanding how the physical and the digital world interact with each other. And this is basically facilitated by having a massive amount of sensors, actuators, and understanding how they help with all of the predictions in order to provide better services for all sectors. So as you can see, Aryan, sustainability can be part of any of these use cases and any of the architectural pillars. In my work, basically, we focus on how we can understand the environment, the propagation environment, in order to facilitate the resources in a sustainable manner. So if we have an understanding of the environment, say, for example, the users, their traffic patterns, their potential blockages that they might undergo, then we will have a better design perspective on how we can come up with a system that is capable of taking these environmental aspects, putting them into constraints, and designing efficient solutions, taking into consideration the power consumption and energy efficiency, but at the same time without compromising on the experience of the users as well, taking into consideration that they might request different services, because we would see in 6G that there's going to be heterogeneous services. So the complexity here is how we can deliver the sustainability that's anticipated for, but with all of these ecosystem interactions. And the look forward is to have a system of systems. So we're not talking about intelligent transport on its own, or intelligent, let's say, homes, smart cities on its own, or intelligent sound, Internet of Sounds on its own, or intelligent industrial sites, but we are looking on how these systems interact with each other and how the knowledge or the understanding from one system can be learned and shared into another system. So this systems of system thinking in a federated manner, of course, because there's privacy concerns here, is something that we really interested in.
Very nice, Lina. Thank you. But it looks like very sort of like complex scenario in a way, because you have to manage these on-demand things. Basically, I mean, you have multiple service providers, multiple sort of consumers, right? So basically, to really design systems of systems, or something about, let's say, massive connectivity sort of solutions, right? So you really need some additional architectures other than what exists already in 5G infrastructure, right? So basically, you need to plug in some additional things that can actually make this sustainability factor stand out, which is not really visible with our, let's say, 5G infrastructure as such, right? So what do you think that how we can overcome, let's say, these complexity issues that we are facing to provide massive connectivity, right? So are there any sort of works that you have been trying to explore in terms of energy efficiency, in terms of achieving, some sustainable goals using machine learning, or, machine learning in itself is a bit of complex area, because, you're trying to implement, you're trying to sort of train your models in a way more efficiently, but you require a lot of power, you require a lot of processing, you require a lot of training of these models and so on, right? So it does take a hell lot of, let's say, time and sort of complexity issues there are. So how do we actually overcome this in the long run? I mean, any work that you have been developing around these using machine learning and trying to achieve energy efficiency and so on? Yeah,
indeed. Yeah, I'd like to reflect on a framework that we're doing on vision-aided communications.
Right.
Which is basically relies on having multimodality data coming not only from the wireless data, but also from images, which are captured from cameras deployed in streets. So the idea over here is that how we make use of this multimodal data in order to predict user blockages before they take place, and then hand over the resources into nearby base stations, or even reflect the signals from reflective surfaces. And of course, as you might imagine, the more complex the scenario is, so the more users we have, the more different traffic patterns they request, the more complex the learning process is.
Sure.
So what we did is that we thought is, instead of relying entirely on a centralized machine learning approach, and then which is definitely very, very, which can provide really accurate results in terms of predicting blockages and then steering the resources accordingly in a proactive manner. But there was two issues here. First of all, the complexity of the AI that we are implementing, that it might it might consume a high amount of computational power in order to deliver the outcome needed, and the privacy. So we thought of why can't we tackle like two birds in one stone, right? Mm-hmm. So first of all, what we can do is to do it in a distributed manner.
Yeah.
So we can have different base stations applying the learning in a privacy-preserving manner using federated learning. In this way, each of these base stations will have an understanding of its surrounding environment, but also then there's going to be a shared global understanding of the overall environment. And then this shared knowledge can be transferred to a newly plugged base station.
Yeah.
So in that case, we wouldn't really be relying entirely on a single failure of, let's say, of a node or a bottleneck. In that case, each of these entities can learn the environment in a distributed, privacy-preserving manner. Each one of them understanding the complexities of their different users associated with them. And you can imagine there might be different cases arising from different particular scenario or area of focus. And once we reach this global knowledge, if we have a newly plugged base station, then the beauty of the federated learning is that you can transfer the knowledge, which means that we don't really need to retrain the model all over again. And this significantly reduces the amount of training needed if we are to plug a centralized approach altogether. So, what we did over here is that we created a data set. It is a synthetic data set, but also representative of what real scenarios we could face into 6G.
But is it publicly available, the data set, or is your own?
It is not, but the features of it, we did, it is available on a paper.
Yeah.
And it is, we have listed what sort of scenarios we are dealing with. And the benefit is that once the training model converges, and so it acquires that learning and everything, it was very interesting to transfer it to a newly plugged base station. Mm-hmm. And that base station was immediately able to capture the potential blockages in its own environment, local environment, and do the blockage predictions beforehand in a proactive manner. Because for 6G, we need to move from having reactive sort of mechanisms into more proactive approaches in order to meet all of these real-time scenarios, mission-critical demands, which are very, very time-sensitive.
Exactly, as for public safety and disaster management scenarios, I think it's very useful that you can actually figure out already how you are going to basically handle the situation using different methods and techniques that you're mentioning as well. So as you said, mission-critical, I think is a very good sort of example or use case of some of these technologies.
Indeed,
yeah, that's great. So if you would like to also sort of expand on this Internet of Sounds and sort of this Internet of Music, I mean, this sounds very amazing, like in terms of like combining music with 6G. Is it like 6G related, like?
So it is 6G related in a sense. So it is Internet of Things related, but it has its own, let's say, particular specifications. And this is, of course, brought by the different trends.
Yeah.
For example, having live concerts of musicians based in different geographical areas and having to deliver the user experience that you would expect when actually sitting in an auditorium or in a concert hall. And imagine this need to be delivered in real time, no matter what the connectivity is.
Yeah.
And all of these sensory sort of, let's say, elements where the users not only would be able to listen to the sounds, but maybe, have some haptics associated with their receiver device, so that they can sense the haptics coming out of these music.
Nice.
And this is driven from my background as someone who plays piano and who enjoys the music. This
That's
got me
a nice
really
plug-in for of your talents here.
Yes, indeed. So it was driven by that, and I was inspired by a group in Italy that who pioneered basically this this area. And at Glasgow, we looked at it from the perspective of synchronization and energy efficiency. Because the demand here is how we can deliver all of these quality of audio and control in a synchronized manner, no matter where the geographical area of the audio source is, be it the music players, or sometimes a person doing music therapy over the wireless connectivity. So the idea is that we want to facilitate this synchronization, but at the same time, we don't want to put an additional strain on the network. So we have resorted to the use of semantic communications, which is basically having this awareness of the environment and the user feedback in order to send the semantics over the network, and then for the receiver to have this sort of reasoning where it can create that audio back at the receiving end.
Yeah.
So without the need of transmitting all of the data in a bit-oriented communication, which is the traditional one, the idea over here is how we can reduce the strain on the bandwidth with using less amount of data, which will naturally use less amount of power associated with it, and then send that knowledge or understanding, the semantic, over the network. But the idea is how we can collate all of the audio sources coming from different, music players, let's say, of different geographical areas, and imagine each one of them will be susceptible to different network reliability links. You might find one of the channels is highly noisy, the other is might be susceptible to blockages, and so on.
So is it like range constrained, or it can be like, even broader sort of like applications? For example, if a musician is in London, so it can also be in some other city far away, some other country far away. You can actually put this on internet and regulate the whole thing. Is it like that, if I understand
indeed.
correctly?
So there is a rise now in smart musical instruments. So imagine a piano or a guitar having sensors and actuators. And this piano or guitar is able to send through the system live feedback on maybe the variation of the notes or the frequencies and the associated gestures of the players. So imagine there's a pianist in London and then a guitarist in Dubai, for example, and then a percussionist in Singapore, for example.
Right.
Okay?
So they can all synchronize.
They want to synchronize, to play a musical piece. And that's to deliver a live concert to audience who might be in the US, for example. And this is what is basically complex over here, is that you have multiple sources. They need to be synchronized. But at the same time, we want to facilitate it in an energy perspective manner. So lots of interesting thing in that domain, in that area, which is very unconventional.
We have seen sort of like holograms and all, like with these.
Indeed, and then you can you can get the hologram of the player and the theater, the virtual theater. It could be a virtual or an immersive theatrical experience, for example. So imagine yourself, you want to listen to a concert that is played in Vienna, but you're sitting from your home in London.
So you never have to go out of your house, is it?
Absolutely. So that's how the wireless infrastructure is supporting sustainability, because it reduces the travel while it gives you this, experience.
Right. So indirectly, you're also saving on the carbon emissions and stuff, is it?
Exactly. So sustainability comes in different manners and different shapes and different hats.
Interesting. So what do you think, like, what could be, let's say, the future of this thing going forward? So in terms of course, like 6G sustainability, and with all these new terms that are coming up, new technologies that are coming up, what do you think, let's say, next 5 years, 7 years, 8 years, how we are heading forward? So do we actually have, let's say, the objectives defined very well, and then we are working on it and with a rapid sort of like outputs and outcomes and so on? Or do you think it's something that we see perhaps in 7G being more mature or something like that? Do you think that we can actually see these technologies in hand, in person, during 6G sort of time?
Well, I think there's a lot to be done here. It might, I mean, the road towards 6G, which is not too far, really. I mean, if you think about it, 2030 is not too far.
Yeah, it's quite close.
Yeah, but there are some missing capabilities. As you mentioned, there is the standardization and interoperability between all of these entities, because all of these systems, they belong to different owners, but they need to be, interplaying with each other. They need to be, maybe sharing the resources, sharing the data. So there is a need to define the interoperability mechanisms, the standardizations, of course, and also how we can relate all of these to the user experience and the social impact and the economical impact. So this is where the 6G and perhaps 7G is going forward to. It is because it is not only communication oriented now, it is also human centric and data centric and mission centric. So one of the things that also we are very interested at is how the communications can support robotics who are working on the life cycle of the inspection, maintenance, and repair of the net zero asset. Like we are anticipating hundreds or thousands of robotics to be operating in wind farms, solar farms, and etc.
Yeah.
But we haven't thought about how we basically promote this autonomous connectivity. And what is the interplay? So there need to be an understanding between people working in communication, people working on hard robotics, and people working in soft robotics. And this is one of the aims of a Central of Doctoral Training that I am a deputy director for, which is called RAINS, or Robotics and AI for Net Zero.
Is it based in Glasgow?
It is based in Glasgow, and it is with a partnership, in partnership with University of Manchester and University of Oxford, with Manchester leading, together with about more than 10 industrial partners. At Glasgow, we are looking at the connectivity and having this 6G empowered robotics, what we can do to have this coordination of tasks between robotics in very highly dangerous environments, or maybe they are doing a mission critical, let's say, approach. And in here, this would bring me to the fact that there is a need to apply integrated sensing and communication. And I know you have also been working a lot on this area. So it's now my turn now to ask you. So I would like to understand, how do you think the integrated sensing and communication will really facilitate the road forward towards not only 6G robotics, but this, the simultaneous sensing and communication? What are the potentials? What are the doors that it opens? And the use cases we can apply
I think it's very, in my understanding, I think it's very use case oriented. So basically, if you're requiring, let's say, to use 6G for robotics, so you need like very high accuracy sort of sensing capabilities. You require, let's say, you also need to also be careful about the security and privacy concerns, like you can't be really sensing everything around you, right? So let's say if you're trying to provide robotic sort of application using automated guided vehicles, or you want to use your non-terrestrial entity or something. So in those scenarios, I think it's very important when you have like large distances to cover. So you want to make sure that the estimation accuracy that you have for whatever you are sensing, right, is as high as possible. The accuracy level is like centimeter level accuracy, they call it. So it links to basically localization, positioning, and so on. At the same time, when you are having these large distances to cover, so you want to also be sure that your sort of connectivity is private enough, secure enough, right? You are not basically sort of playing around with some sensitive data or something, right? So that is also one important thing. You can also use sensing for, let's say, disaster management scenarios. It's like a public safety use case that you have. So basically, you might be trying to find some sort of like stuck people, or some, let's say, vehicles that are stuck, or any sort of infrastructure that you're actually looking for, to recover. So this can be quite useful there as well, that you're basically setting up the connectivity with your broken infrastructure. at the same time, you're also trying to sense, and it helps in your search and rescue operations and so on, right? In terms of like, I mean, you asked like not only robotics, but like other applications that you can think of is of course in vehicular networking scenarios is very important. So let's say you have driverless cars, right? So basically that can, you know, sense like where is the next pedestrian, where is the next traffic light, where is, let's say, basically if you're looking for these intelligent meta surfaces, maybe, right? If you want to reflect your signal, so where are they when you are actually, you know, going on road, right? Or if you have your drones and stuff, so they can also be automated in a way that they are able to sense their environment. So basically, if there are any other drones or any other AGVs around them, right? So it can also help in multiple things, right? So basically, they can coordinate and they can basically work together. All these entities work together more effectively. So there, you have to have some good sensing capabilities on board. In addition to whatever you are doing with your communication cycle, right? So that's the addition that we are doing for 6G when we talk about 6G. It also links to sustainability in a way because, of course, I mean, exploring sensing and communication is not a completely new idea, but the developments that are happening right now, the sort of standards that we are bringing forward, right, the pre-standards activities and standards. So basically the things that we're fixing around with channel modeling and because they have different channel properties and channel characteristics and so on, right? Different sort of electromagnetic properties as well. So how, let's say, a radar sensor works, how a communication operator or whatever works.
Yeah, and then there's the waveform design. So you have the channel measurement, the waveform design, and the front end.
Exactly. So that has to be effective as well. So my point of mentioning all this is that this also links to sustainability in a way, like the topic of our podcast, is that basically you're trying to provide multifunctional connectivity, right? So basically you don't have to use a different sensor and different communication equipment.
Indeed.
These can be basically just one single equipment, right? So your phone, basically, it can be also a mini sensor and it can be, it is a communication equipment already anyway. So the idea is that you combine multiple things together, so it becomes already more sustainable. And back to your point of this waveform design, this is also linked to sustainability because if you design in a way is that that you are able to hop in extra information on the same communication waveform that you have, you're able to sense entities and you're able to like sense any targets, objects, or whatever that is, right? And you're able to communicate at the same time using the same waveform, which is basically simultaneous information that you're exchanging. So basically, that is also a sustainable solution.
Indeed, yeah, because you're doing like a dual use for the same electromagnetic wave.
Exactly. So I mean, in the beginning, we used to have this term called dual function sensing comms or dual function radar comms, like that. Now it's switched more to integrated because people try to come up with different aspects of it. So they say whether you have a communication system, which is the main operation that you have, and sensing is just sort of complementing that. Or you can have, let's say, a sensing system, a sensing equipment, and communication is just one complementing function, right?
Indeed,
so let's say if you are, you want to, I don't know, sense any flying platforms or any sort of airplanes or something, right? So basically, you want to sense them, so it is a radar actually, but you need to also collect that information and maybe pass it somewhere.
Absolutely.
I mean, it's just a simple example, but
Yeah, this is really fascinating because this taps on the idea of control. So in 6G, we will have a closed control or closed loop systems, but then each system have its own closed loop feedback sort of control mechanism, but then how to resolve conflicts between all of these closed loops and how to facilitate this flexibility on a scalable manner. So integration is the key, definitely, and the people working from different disciplines, they need to come together because this is the way forward. I mean, it needs to be embedded in the fabric of the 6G network infrastructure.
Oh, that's true. I mean, again, I mean, this is very important, as you said. It's perfectly well put. The only thing is that we have to see how we proceed further because there are some technical and non-technical challenges that we are facing. So first is, of course, security and privacy, as I was mentioning earlier. That is the most important thing that we need to think at this moment when we bring on board the sensing capabilities, right? So, I mean, we do have some updates in standards and pre-standards around these ideas, but again, we are not mature enough in a ways that we still are evolving in terms of the technology of this integration that we're talking about.
What do you think is needed for these standardizations to mature?
So basically, it has to be like, let's say prolonged discussions. So among the community, so they need to basically work on what can be some technical solutions or no technical solutions. So let's say industry provider, the service provider, is trying to provide services to the sort of mobile service user, right? So there has to be a consensus that these are the sort of services we will provide, right? At the same time, so the guys who are, developing these policies and which data is sensitive, which data is not, and basically what kind of restrictions or regulations they put, these compliance sort of regulations. So they need to sort of go hand in hand with the industry service providers, the government organization. They need to like work together with these industry guys. And academics, I mean, our role can be that we come up with all these nice ideas and then we sort of, provide them the sort of roadmap and stuff that look, we can do this. Of course, we do some approximations on ground, maybe it's a bit different story. But the idea is that all these communities have to come together to basically discuss more about this, which, in every standards meeting, so like 3GPP meetings, every time they are defining new sort of system aspects and requirements that are used for ISAC. The good thing is that they are very use case oriented. So it means that you are thinking already in sort of practical terms, right? So you're not just discussing as a concept. You are basically also trying to see the practical sort of implementation of this technology. Right, and again, you come up with multiple different vendors who have multiple different sort of businesses, right? So if a person is working in robotics, so I was in the other day in some conference. So basically, they were showing some demos about robotics and so on. So basically, you have your virtual headset and you use your let's say the remote, let's say you have in your hand, and you're able to actually control the sort of movement of the robot just using this, and this is all wirelessly happening. So this is a good example. Like other industry partners, they have shown some sort of simple demo with, let's say, you just sort of type the command, and then the sort of robotic arm is able to sense where is the next sort of product or whatever. I mean, they're trying to pick like banana or apple or something. So they're trying to differentiate which one is apple, which one is banana, and they are able to sort of pick that up. So it's something that like a simple demo, but the idea is that that we are already thinking in practical terms. This is very good, sort of the way forward. But I do think that maybe with 6G Advanced coming in, maybe beyond 2030, so we might have much better observations around these technologies. I mean, we would be able to see, like with any other technology, that first we test it out and then we see that how it progresses, and then of course it matures.
So it is also about a matter of building trust throughout the process. Trust in how we do things, how we decide on which approaches and mechanisms we want to apply, even trust in AI approaches, for example.
It's very important, Lina.
Intent-based AI, explainable AI, and all of that to support different aspects, not only sustainability.
Is very important. That's whether you really trust the sort of outcome that you're getting from your AI model or not.
So there needs to be a lot of
ethical AI, they call it.
Indeed.
What can you do, what you cannot do.
Sort of a trusted approach, trusted entities at scale, at that level of distribution. So, I mean, what we could do as academics is to steer the research forward and to provide this opportunity to deliver demonstrations to policymakers, standardization bodies, so that they would be the first observers of the potentials of 6G really and what it could do.
Very nice, very nice. I think that's very well put. So before we sort of like conclude our podcast, so would you like to mention something about our ongoing works that we have been doing, you and I?
Yes,
groups?
Absolutely,
So some work with NTN, ISAC combined with federated learning and some things.
Indeed. So really exciting stuff going on. So we are looking at how reconfigurable intelligent surfaces can assist the UAV-based communications in order to do real-time data collection from IoT devices serving different applications. And the idea over here is how to jointly configure the RAS phase shifts as well as the trajectory of the UAVs taking into consideration the scheduling of the IoT. But as you mentioned, Aryan, the idea is how we can do it in a privacy-preserving manner. And here comes the play of, or the role of federated learning, which is basically the application of having this level of understanding in a more privacy-preserving manner, where understanding the features of local entities is kept and no raw data is shared, but only the training features is shared to a global, let's say, server in order to provide this global understanding. And that's what's really interesting, because then if you can plug a new scenario or a new entity into the network, it can understand from that previous entity and then share the knowledge immediately. Would you like to reflect on anything else?
I think you summed it very well. I think I'm quite intrigued by these ideas. I mean, we have been discussing it over some period of time now, like how to sort of work around this combination of different technologies together.
Integration, we're going back.
Integration as well. I mean, so I think we did publish some paper as well recently around this idea of using NTN, let's say UAVs and so on, and plugging this with ISAC and so some sort of system that we have generated, and using RIS as well, I think.
Yeah.
And that is going to be also like expanded in some other sort of forms of publications and so on.
Yes, yeah, because there is a lot to work on here in that case, because if we look at application-oriented or goal-oriented approach, then we can take the tools that we've built, readjust it in order to provide this bespoke solution to other scenarios that we want to cater for. And then there is, for example, there is the potential of having these UAVs communicating with each other in a coordinated manner, but then how we can select the best RIS to facilitate or to support which UAV and which IoT devices are connected to which UAV.
Again, this links to sustainability aspects.
Indeed, because we want to minimize the hovering time of the UAV. We want also to ensure that the scheduling of the IoT devices is done in line with the available resources of both the IoT devices and the UAV, as well as what the RIS can support. So it taps on sustainability.
Great. Yeah, I think that this is great. I think we also look forward to sort of deliver some tutorials together, Lina, right?
I'm very much looking forward for it.
On this research that we have been working on. So basically, so our audience, I think they can hope in for some of our tutorials that will be delivering together at some IEEE ComSoc conferences that are coming up. And also, just last thing, I think before we go, I would like to mention, Lina, you also run some sort of PhD advice channel.
Indeed.
So if you would like to advertise your channel,
yes. So this is
for students who are looking forward.
This is a brand new initiative that I have launched very, very recently, which is basically helping PhD students and early career academics, including postdocs and lecturers, to navigate their way in academia. And I'm sharing some of the survival tips, what I call, in order to make this journey less overwhelming, a bit more enjoyable, and less daunting. And the fact that I'm creating a community here is to have this space where people can share their journeys and experiences in a very open and relaxed manner. So I'm running online seminars frequently, and people can join too.
I think that's a very good resource, Lina. Hopefully, I mean, many people can actually take
thank you so much
from this. And okay, so with this, thank you so much, Lina, for being with us. And hopefully we catch up again and do some sort of like another podcast.
Indeed.
After our tutorials and so on. So maybe you can share your experiences further on the technology.
Thank you so much, Aryan, for having me. Really pleasure to be here. And this is just the start of the discussion. Always happy to do joint work with you and to share our expertise and tutorials, workshops, and any other sort of.
Perfect. Thanks, Lina.
Thank you so much.
Take care.
Thank you.